Welcome back, class. Thank you for joining me. So far we have done multiplication and division. Now today we're going to focus on the addition and subtraction side of all these rational expressions. Now, you hopefully remember back when you started adding and subtracting fractions that if you have a common denominator, so here when you're adding these two, they have a common denominator. So really all you have to do is add the numerators together. So you take 5x plus 10x, combine that into a single fraction, factor, and then cancel based on what we've been doing this chapter. All right, so again, pretty basic as long as you have a common denominator. However, when you don't have a common denominator, hopefully you remember that the first step is to get one. They have to be the same. If they're not, then there's nothing we can do with the fractions. So, if you think about a common denominator, you have to have every piece of both denominators in that common denominator. That means of the factors and of the powers of monomials. All right? So, let's take a look at steps to finding and subtracting, or steps to adding and subtracting rational expressions. First, if possible, you want to factor. All right? You have to factor them. Then determine what should be used as a common denominator. Use multiplication to convert each fraction to having the common denominator. And now you can add or subtract the numerators. Then, if possible, you can refactor and cancel. So let's take a look at what I mean by these steps. All right. So for this first one, 4 over x plus 7 plus 2 over x minus 7. Well, if you notice here, those do not have a common denominator. Now, the nice thing is this one also doesn't factor. All right, there's nothing here that factors. So all we really have to consider is getting that common denominator. Well, that common denominator, think about it, if it needs every piece, the common denominator is going to need the x plus 7 and is going to need the x minus 7. All right, that's what that denominator is going to be because, again, it needs every piece. So if we think about it, over here, this fraction needs the x minus 7. So I'm going to multiply top and bottom by that x minus 7 because that's what that one needs. And then the other side, well, the other side is missing the x plus 7. All right, so that's how you deal with these. You find out what does the common denominator have to be, and then you're going to multiply top and bottom on those fractions to manipulate them to having that common denominator. So what's going to end up happening is I'm going to have 4 times x minus, oh, started writing the wrong symbol there. I'm going to have 4 times x minus 7 from the first one, and then I can add in that 2 times x plus 7 from the second fraction. And now that I've done that, now I'm ready to start simplifying this. Well, by simplifying it, I can distribute that, so I can get 4x minus 28, and then plus 2x plus 14 over that common denominator. And now 4x plus 2x is going to be 6x. Negative 28 plus 14 is going to be a minus 14 over x plus 7, x minus 7. And the neat thing is, I'm not going to make you factor out that denominator. You can actually just leave it looking like that. All right? Now, if you wanted to get really fancy, I would also think it's neat if you pulled out a 2 from the numerator to get that, but either answer will suffice for me. But if you want to take a step further, factor out that 2 on top, awesome, even better. All right, so that's kind of the basics of this. So let's take a look at another example. That's 3 over x plus 4 plus x over x minus 4. So again, the goal here is we need that common denominator. Well, here our common denominator, if we need every piece represented, we're going to need the x plus 4 and the x minus 4 together as our common denominator. We need every piece represented. So what does that mean for us? Well, what that means is this side over here is missing the x minus 4. This side over here is missing the x plus 4. So what does that mean? Well, that means from the first one, I'm going to be getting the 3 and the x minus 4. Then from the second one, I'm getting the x times the x plus 4. So now I have them written with a common denominator. Now all I have to do is simplify. And by simplifying, means I'm going to distribute those. So 3x minus 12 plus x squared plus 4x over that common denominator. All right, now let's combine like terms. Well, on top, I see x squared. Then the 3x and the 4x makes plus 7x, and then a minus 12 over x plus 4, x minus 4. All right, now we need to see if we can refactor that. Now, two things that multiply to give you negative 12 and add to positive 7. If you search for all those combinations, you're going to see that there isn't anything that actually works for that. All right, so I'm not going to spend my time showing you the guessing and checking of it. It's not going to work. So we can just leave it written like that. And again, that common denominator, you don't have to FOIL that out or anything. Just leave it as is to make it easier for yourself. All right. Now for subtraction, make sure that you're subtracting the entire second fraction, not just the first term. Make sure whenever you have to distribute something out in that second fraction, make sure you're distributing the negative with it. All right. Now if you notice this time we have something unique happening, okay? So notice this piece right here, I can factor that. So that's going to be my first step, is I'm actually going to factor that piece. So I'm going to scooch it over to give myself some more space. So x squared minus 9, remember difference of squares, x plus 3, x minus 3, minus 2, and then x minus 3. All right, so if I need every piece represented in a common denominator, what that means is I need x plus 3, x minus 3. Those are all the pieces that I see in the denominators. Now, that also means, look at this first fraction here. That first fraction already has both pieces, okay? So what that means is I actually don't have to manipulate that first fraction at all. It already has a common denominator. It has both pieces in it. So I don't have to worry about that one. The one I have to worry about is this one, because this one is missing the x plus 3. So it's that second one that I have to be concerned with at this point. That's the one I have to manipulate to have a common denominator. So what does that leave me? Well, the first one is just a 5x. It's not changing. And then I'm getting that minus 2x plus 3. All right, so let's simplify this. So 5x, then minus 2x minus 3 over x plus 3, x minus 3. Well, 5x minus 2x gives me 3x. Then finally on the top, I can even pull a 3 out to get x minus 1. Now remember, the bottom just stays in its factored form. Now notice still nothing actually cancels, but you want to check. So do factor out that 3 just to check to see if you're going to be able to cancel anything. In this case, you can't, and so you just leave your answer in that form. You can leave it in factored form. All right. So let's take a look at our last example. Now again, I want you to notice that the bottom of that one actually cancels, or factors, I mean. So we have x plus 3 over x minus 2 minus 6x minus 7. And now if I factor that piece, I'm going to get x minus 2, x minus 1. So if I have to represent every piece of the denominators in a common denominator, those are the only pieces I see in the denominator. So what does that mean? Well, it means that one is already complete. That one already has both of those pieces, so I don't have to worry about manipulating them into a common denominator. It already has it. The one I have to worry about is this piece right here, because this piece right here is missing that x minus 1 piece. All right, so what I end up getting is that x minus 1, x plus 3 multiplied, minus the 6x minus 7. Now notice when I'm subtracting, it is important that I use those parentheses, because that's what I mean by make sure you actually subtract the whole thing, not just the first term. That negative affects both of them. All right, now, this first piece right here, that is going to take foiling in order to break it apart. So when I FOIL that, I'm going to get x squared plus 3x minus x minus 3. And then when I distribute that negative, I get a minus 6x plus 7 all over that common denominator. All right, now let's combine our like terms. Well, I see an x squared. Then I see a 3x minus x, giving me 2x. 2x minus 6x is a minus 4x. Then I see a negative 3 plus 7. Well, negative 3 plus 7 is a plus 4. Now I get that. All right. So now let's think about this one, because again, you always have to see if the top factors. Well, this time, actually, the top does factor. All right. So if I refactor that top, I'm getting x minus 2, x minus 2. Okay, two things that multiply to 4, add to negative 4. Over x minus 2, x minus 1. Well, this time something really awesome happens. This time we can actually cancel out those x minus 2's to simplify this even more. So the really neat thing is, after all of this work, you actually get to simplify it down to just this. Right? So look at where you started and where you ended up. A whole lot simpler, right? So this is one that I think is really cool. This is the full power of adding and subtracting these rational expressions, because you can sometimes simplify them down to really neat things. All right, So thank you for joining me. That is going to be all for our notes today. Now, please make sure that you write all this down so you are ready to do your practice work when you come back to class tomorrow.